Hello class. In the second part of activity 10, we're going to be doing more with quadratic graphs, but we're actually going to look at x and y intercepts today. And we are also going to practice writing some equations of graphs using the intercepts. So the first thing we're going to do today is review how to find the x and y intercepts when we're looking at a graph. So we want to start by identifying both the x and y intercepts. So remember, an x-intercept is the place where the graph crosses the x-axis. The y-intercept is the place where the graph crosses the y-axis. So we have a couple linears and then we have a couple of quadratics. So linears should be reviewed to us. The y-intercept will be right here. That's the place where the graph crosses the y-axis. So that looks like it's up at 2. The x-intercept is right here, which looks like -2. In the next function, the y-intercept is -3. And remember, you also could find that from right there. That's the y-intercept. That's if you remember the b in the y equals mx plus b form. And then the x-intercept, well, that's right here. It looks like -1. So x-intercept, -1. Y-intercept is at -3. We also use intercepts to help us graph parabolas, and so we can, again, locate the y-intercept on the graph. Here it is. It's up at 4. But notice it has 2 x-intercepts. It has one at +2 and one at -2. So it has x-intercepts at 2 and -2. Finally, in our fourth example, we have a y-intercept. Right here, it looks like it's at -3. Okay, again, notice we see that hanging off the end of the equation, very similar to our linear. It also has 2 x-intercepts. Okay, you might think all parabolas have 2 x-intercepts, but that's not actually true. We're going to think about how many intercepts a parabola could potentially have. So I see one at -1, and I see one at +3. Since y-intercepts occur when x equals 0 and x-intercepts occur when y equals 0, we can find them algebraically. So to find a y-intercept, remember you can plug in 0 for x. And to find an x-intercept, you can plug in 0 for y or for f of x. Okay, so let's do these algebraically. We can kind of verify our answers from above by using algebraic methods. Okay, so let's look at the y-intercept says to let x be 0. Okay, so this is y equals 0 plus 2, y equals 2. Now the x-intercept will have us let y be equal to 0. So 0 equals x plus 2. Subtract 2 from both sides. -2 equals x, and that should match with what we have above. Okay. Y-intercept is kind of easy to do. When you let x be 0, you're sort of just left with the constant. Y equals -3 times 0 minus 3. Y equals -3. X-intercept's a little harder. You have to plug 0 in for y, and then you're going to have to do the steps to get x alone. So we'll add 3. So 3 equals -3. X divided by -3, -1 equals x. So our x-intercept is -1. Okay, so y-intercept on the third problem, if we plug in a 0 for x, we get out a 4 for y, because negative times 0 squared plus 4 is 4. X-intercept is a little different. Now watch what happens when we plug in a 0 for y. 0 equals -x squared plus 4. We're going to subtract 4. -4 equals -x squared. Divide by -1. 4 equals x squared. Now when you square root 4, there are actually 2 answers that make this equation true. Both 2 and -2 squared will get you 4 back, and that's why there's 2 intercepts. So 2 and -2. And in our last one, it's going to be a little bit trickier to get the x-intercept, but the y-intercept can be found pretty easily. If you put a 0 in for x, you're going to get a -3 out for y. You have to put a 0 in 2 places, but they all fall away and you get -3. Now when 0 equals x squared minus 2x minus 3, to get the intercepts, we're going to factor. So 0 equals x times x, and -3 would be -3 plus 1. Let's see if that works. -3x plus 1x is -2x. Then you can set each factor equal to 0. And when you solve, you get x equals 3 and x equals -1. So 3 and -1. And those should match what we saw above. All right, now that last method we're going to work more on in another lesson. That's not our focus for today, but now you kind of see where factoring is going to come in to help us on these problems. All right, so what we want to be able to do ultimately is look at a graph, and we want to be able to see if we can write the equation of the graph based on its intercepts. Okay, so sometimes we're asked to create a quadratic function. Write a quadratic function in standard form, that's ax squared plus bx plus c, whose graph crosses the axis at -3 and 2. That's really all you're going to need to write a function, a quadratic function. Okay? At first this seems difficult because standard form has nothing to do with x-intercepts or zeros, you might think, but we could get this into factored form. So our f of x can be written in factored form first, and the way we're going to do that is we just reverse the sign for the intercept. So if x is equal to -3, then one of our factors is going to be x plus 3. And if one of our intercepts is 2, 0, we are going to have an x minus 2 for a factor. And so for the factored form, we're always going to reverse the signs. Okay, now we can FOIL this out. So we'll have x squared minus 2x plus 3x minus 6, or x squared plus x minus 6, and that's what we call standard form. So we're going to practice a couple of these. Okay. So if we have zeros at 5 and 6, we want to start by writing f of x equals x minus 5 times x minus 6. Then all we have to do is FOIL. F of x equals x squared minus 6x minus 5x plus 30, or f of x equals x squared minus 11x plus 30. Okay, so it's zeros. Zeros are just another way of saying x-intercepts. Okay. All right, contains the points -2, 0, and 7, 0. Well, remember, if y is 0, then that means that these are x-intercepts. So again, I could write my function f of x equals, this time it's going to be x plus 2 times x minus 7. So f of x equals x squared minus 7x plus 2x minus 14. So f of x equals x squared minus 5x minus 14. Another way to say intercepts is to say it crosses the x-axis at, and it'll tell you the point. So in this case, at 0 and -3. Okay, so f of x equals, for 0, it's x minus 0. For -3, it's x minus a minus 3, so x plus 3. Well, that's just x times x plus 3. And when you distribute, you'll get x squared plus 3x. And in our last one, its only x-intercept is at 4. Okay, well, it actually has to have a double intercept. If it only hits the graph in one spot, what that means is, you'll learn more about this in Honors Advanced Algebra, but that means that you're going to have two factors at x minus 4 instead of 1. Because if it's a quadratic, then it has to have an x squared. Okay, so you need two factors of x minus 4. And now, when we FOIL, we get x squared minus 4x plus 16. Or f of x equals x squared minus 8x plus 16. All right, your assignment is to do what we just did, to write an equation for a graph and then